So take out your note packets. We're going to be taking notes on 11.3a. When that's done, you're going to take a quiz on 11.1 and 11.2, and then you can work on the homework for 11.3a. And our objective in 11.3a is to do what we call division by a monomial. You've already done some division, and there's different kinds of polynomial division, and today we're going to discuss division by monomial. It's the easiest kind. Before we do that, though, we're going to do a little review of 11.2. And in 11.2, we learned how to multiply and divide rational expressions. It's going to be really important for you to take note and careful note of the operator between these, because once you get to the test, you're going to be doing multiplication, division, addition, and subtraction, and they all have a different process to them. So it's really important that you note that in this problem I'm being asked to multiply. In this problem, I'm being asked to divide, and these two processes are pretty closely linked, but it's important that we take a look at that operator. Now remember, the number one don't rule for these is to just go in and start canceling things from the top to the bottom. We always have to factor first, and we have a little rule to help us that we never cancel anything if it's living next to a plus or a minus. Meaning it might be tempted, don't do this, to go in and say, oh, the x cancels with the x. But remember, this x is not a factor. It's part of a sum. A factor is a piece of a multiplication problem. So let's go and talk about how we approach these. Our biggest thing we do this chapter almost universally is we factor first. So what I'm going to do is I'm going to take each piece of each fraction and factor it. The top left is a difference of squares. Those are our easiest kind to factor if we spot them, because they lead in the same. X times x is x squared. They end in the same. 6 times 6 is 36. And we do opposite signs so that when we FOIL them, the outside and the inside cancel. The bottom is also a difference of squares, similarly, leading in x times x, ending in a 1 and a 1, with 1 plus and 1 minus. So the first fraction has been factored. The second one, this top is already factored. So I'm just going to leave that as is. On the bottom, it is not a difference of squares, but it does have a factor of 2 that needs to get pulled out. So I'm going to divide a 2 out of each term. Once it's factored, then I can go in and start canceling. So now that I've factored it, I'm going to go in and start canceling common factors top to bottom. I cancel the entire x plus 6 with the entire x plus 6. I cancel the x plus 1 with the x plus 1. I cancel the 2 with the 2. What's left is x minus 6 times x minus 1. And that is my final simplified answer. Remember, I don't cancel those x's off because it's part of a subtraction problem. Again, I like to show you that with numbers just so you can see it. If x was a 7, the top would be 7 minus 6. The bottom would be 7 minus 1, which we know if we actually did the subtraction is 7 minus 6 is 1, 7 minus 1 is 6, and I can see that. It's not what I get when I simply cancel these off. So again, we only cancel factors, or easier to remember, don't cancel if it's living next to a plus or a minus. So then we did division, and division we said was closely linked to multiplication. And our rule for division was that before we divide, we multiply by the reciprocal. And the reciprocal is really what you get when you flip that second fraction over. Now let's kind of just look at that numerically as to why that is a valid thing to do with division, just so you can see it. Because you've probably been told throughout elementary school, you just multiply by a reciprocal. Why does that rule work? Let's go take a look at why. If I were to ask you what is 4 divided by a half, I would say 80% of kids would tell me that that's 2. It just seems to come naturally to say it's 2, because you say half of 4. But of is multiplication. Division means to cut. And so if I were to take 4 pieces of pizza and to cut them each in half, you'll notice that when I do that, when I cut things into smaller pieces, the amount that I have multiplies, and in fact it doubles. So really what I get is 4 times, notice that multiplication, 2, the reciprocal, and I get 8. So you can see that numerically, division is the same as multiplying by the reciprocal. Similarly, if you were to take 8 pieces of pizza and cut them in thirds, you're going to have a multiplication. The amount of pieces you have is going to multiply by 3 if you cut them in thirds. So, having said that, let's go apply that to this problem right here. First thing we do is a simple rewrite. We rewrite the top, we rewrite the bottom. Then we multiply by the reciprocal. So I'm just going to take and flip this fraction over. Then I'm at a division problem. So I go right up to the top and I don't start canceling. I factor first. I like this problem because it's got the 3 kinds of factoring in it. It's got factoring the trinomial, or unfoiling. It's got pulling a common term out first. It's got no factoring. And then it's got a difference of squares. So you really have to have your factoring all ready and lined up to go for this one. Let's start with our trinomial on the top here. Does anything come out before I start? No. Do I have a pair of numbers that I can get a 1 out of that multiply to equal negative 30? The answer is yes. Actually, I need to get a negative 1. We've done those so many times, so I'm confident that you guys are really good at doing that when the lead term is a 1 like that. On the bottom, they're both even, so I can factor out a 2. So there's my first fraction, all factored and ready to go. My second fraction, the top does not factor. The bottom is, again, that difference of squares, which is so easy to do if I spot it. Same's out front, same's out back, 1 plus, 1 minus. Once it's all factored, then I go in and I cancel common factors, top to bottom, even diagonally. So x minus 6 goes with x minus 6. X plus 5 goes with x plus 5. I've also got a 2 living on the bottom. That'll wipe out a 2 living on the top. So make sure you're got everything canceled off neatly there. When I'm all done, I multiply straight across. Well, on the top, I have a 2 left and an x squared left. So I have 2x squared left on the top of that fraction. On the bottom, I have an x plus 6. And again, really key to note that you cannot cancel this 2 with this 6, because the 6 on the bottom is not a factor. It's part of a sum. Again, if x is a 1, there's a 7 on the bottom there, not any kind or multiple of 6. So that one is all done. So now the new stuff. The new stuff for today is how do we divide by a monomial? It's really nice and easy, but first of all, you've got to know when to use this method. In a monomial, remember, that word mono means 1. It's just one term. No separation by plus or minuses, like that 3x squared right here is called a monomial. This 2a squared is called a monomial. Any string like this, where there's no pluses or minuses, it's just one term. Well, what do we do when we divide by that? It's nice and easy. It has to do with the fact that this is a grouping symbol, which means take all of it and divide by 3x squared. So what I'm going to do is take each one and divide it by 3x squared. I call that splitting it up. If all of it is getting divided by 3x squared, then I'm simply going to take it all and divide it by 3x squared. Then what I'm going to do is divide each one separately. But because I'm going to be having some exponents, I kind of have to remember what to do with exponents when I divide. And there's 2 ways of looking at it. The book says that when you're dividing and you have the same base, you subtract exponents, which is great, and it works. But I like to picture canceling that 2 of these on the bottom cancel out 2 on the top, leaving 4 on the top. That way, when it's bottom heavy, you don't run the risk of telling me that this is x to the 5th. 2 of these on top cancel out 2 on the bottom, which still leaves 5 of them on the bottom. And I think that's safer. But had you subtracted the exponents, you would have had x to the 2 minus 7, which is x to the negative 1/5, negative 5. And remember, we've said that negative exponents mean division. So that means divide by x 5 times. So either way, but I actually think it's easiest just to picture canceling off of the variable. So let's go divide each of these. And I take 9 divided by 3, I get 3. X cubed over x squared is going to leave 1x up on top. For my next term, 6 divided by 3 is, and always has been, 2. X squared divided by x squared both cancel off, so there's no x's left. Now if you use the subtraction property for that, where you say you subtract the exponents, when you subtract 2 and 2, you get x to the 0, and anything to the 0 is 1. So either way on this, you get 2 times 1 or just 2, because all the x's cancel. Plus, 15 divided by 3 is 5, and that 5 would be on the top. This x on the top will wipe out one of them on the bottom, which is going to leave an x on the bottom. So basically, all we do when we divide by a monomial is we split it up and write each over the monomial, and then we divide each separately. So what I'd like you to do is, first of all, change this to an 8, because there's a typo on there, and I'm going to give you 1 minute to try this one on your own. So I'm going to write you try, and that should be all we need for this section. So 1 minute for you to try that one on your own. About 30 more seconds. Alright, so let's go through the process. When I notice that I'm dividing by a monomial, really what that means is it's all over 2a squared, or it's all divided by 2a squared. Sometimes you'll see that written like this. It's the same thing. That means every term gets divided by 2a squared. I'd have 4a cubed that I'm dividing by 2a squared. I'd have 10a to the 8th that I'm dividing by 2a squared, and I'd have 3a that I'm dividing by 2a squared. I do them each individually and arrive at my answer. 4 divided by 2 is 2. 2 of these a's cancel out 2 of those, leaving 1 on the top. First term, done. 10 divided by 2 is 5, and I have 8 a's on the top and 2 on the bottom. So I'm going to end up with 6 of them up on the top. Now, if you're not paying attention, because it's really easy, because it kind of is in this section, tune back in just for a second here and keep an eye out for this one. Because first of all, don't make it a decimal. 3 over 2 doesn't reduce, so just leave it as 3 over 2. 6 over 2, make it a 3. 3 over 9, make it 1/3. But 3 over 2, you can't cancel anything out, so just leave it like that. Also, beware on this one that the A on the top cancels out 1 on the bottom. It leaves the A down on the bottom. So just be a little careful with that. Hopefully you got that one right. So in the last minute here, I'd like to give you the specifics of your homework. This is homework 11-3A. It's from the book. It's very short. It is due on Tuesday. Before you work on it, though, you're going to take a quiz on 11-1 to 11-2, and I don't normally allow notes on quizzes, but for this one, I'm going to allow you to use your notes since we aren't doing any review for it beforehand. So you should take out your notes, or page back, to 11.1. You're going to take a quiz on 11.1 through 11.2b. It does not cover anything up above. Once your quiz is done, you can go ahead and turn it in on my front desk, and then you can work on this book assignment. You have a happy Easter. See you guys.